Hi everyone, welcome to my channel, Truly Test Prep. Today we'll be going over Ottocento number 12, Sine and Cosine Properties. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay everyone, so you may remember from the video we were going over last week, the topic we were going over last week, SOHCAHTOA. And I briefly mentioned in that video that you may notice that the sine of one angle is equal to the cosine of the other. This is what we're going to be talking about today. Now, what the SAT, one way you can visualize this is that when you switch from angle A to angle B, the opposite and the adjacent switch places. However, this isn't what the SAT expects you to know. What they want you to realize is that this happens because this happens with angles that add up to 90 degrees, and these two angles add up to 90 degrees. Think about it. A triangle is 180 degrees. If you take away the 90-degree angle, which is C, you're left with 90. So A and B must add up to 90. A word we use that you don't really see on the SAT that often, but that you will hear me use a lot for the rest of the video is complementary. So that's how we describe two angles that add up to 90 degrees. We say they are complementary. Great. So here are the most common contexts you're going to need to be on the lookout for when you do these types of problems. Well, the one we just went over, which is pictured on the left here. When you see a picture just like this, x plus y add up to 90. And we call these the acute angles of a right triangle. And this picture here, you see we have a right angle and then two angles kind of touching. They form that larger angle, so by angle addition, they add up to 90 degrees. And we call these adjacent complementary angles. Adjacent means next to, and complementary we already talked about. So these are the two things you're going to be on the lookout for. Make sure you write these down. All right. Okay, property number 0. This one isn't as important, so that's why I called it property number 0 instead of starting at 1. Cofunction identities. So cosine of theta is equal to sine of 90 degrees minus theta, and sine of theta is equal to cosine of 90 degrees minus theta. These are quite literally fact check questions. You're going to see on the examples we're about to do. If you know the formula, you get it right. If you don't know the formula, you get it wrong. It is that simple. Lastly, I'm going to put this on every slide for all these properties, but please, please, please don't forget that 90 degrees is equal to pi over 2 radians. I've never seen an SAT question before where they have like sine of pi over 2 minus theta. I've never seen an official test question like that. However, you could swap out, if you're in radians, you could swap out all these 90s, everywhere we're doing 90, with pi over 2 radians. So just kind of keep that in mind just in case. Okay, great. All right, so for this one, they give us sine, and they ask us for cosine of 90 degrees minus x degrees. Well, as we just talked about, sine of x is equal to cosine of 90 degrees minus x degrees. So we can sub in sine of x with 9 over 41. And that's the answer. It's a very deceptively easy question. The only piece of information they gave you is literally the answer. You don't need to go draw a triangle. You don't need to go do anything. This is just something they're testing you on that most people don't know. Okay. Next question. This one's a little bit more involved, but it's the same idea. So again, literally a fact check question. They're just asking us what's equal to cosine. Well, as we talked about on the previous slide, cosine is equal to sine of 90 minus theta. The only answer choice with that in it is answer choice C. And that is it. That's the whole question. They're testing you to see if you knew that formula. Great, let's move on. Okay, now we'll go over property number 1. Trig to complementary. So if sine of x is equal to cosine of y, then that means x plus y equals 90. So if you want to remember it in words, essentially, you're going to add up what's on the inside to 90. And that's how you're going to set up the problem. Once again, 90 degrees is equal to pi over 2 radians. So if you don't see a degree symbol and you see a pi over 2, it's probably testing you on the same concept. Okay, so I see sine of x equals cosine of 10 degrees. And sine is equal to cosine. That's what we just talked about in the if part of the if-then statement. And so we're going to take what's on the inside and add them up to 90. So x plus 10 is equal to 90. Subtract 10 from both sides. That means x is equal to 80. And that would be our answer. Great. Okay, same kind of idea here. I see cosine is equal to sine. That means the things on the inside must add up to 90. So I'm going to write down r plus 59 is equal to 90. Subtract 59 from both sides, and we get r is equal to 31. So that would be our answer for this one, 31. Great. Now these can get more complicated. So if you look at this one, you'll notice that they gave us this picture, which doesn't even really matter. They already are telling us in the question statement that sine is equal to cosine. And we're essentially just going to do the same thing. It's just a little bit more work because the equation is a little bit more convoluted. So sine is equal to cosine. So that means the stuff on the inside must add up to 90. So we're going to write a plus b is equal to 90. Then we'll sub in what they told us. A was 5k plus 28, and B was 7k minus 13. You don't need parentheses here because this is addition, and parentheses don't really do much when you're adding. However, I did that for teaching emphasis, but also you probably want to get in the habit of putting parentheses anyway, because if there were a minus sign there for some other problem, some other type of topic, literally anything, any word problem, you would have to remember to distribute the negative and all that. So I would just get in the habit of putting parentheses. Anyway, I digress. So we combine the like terms. 5k plus 7k is 12k. 28 plus negative 13 is 15. We subtract 15 from both sides. We get 12k equals 75. And we divide both sides by 12, and we get k equals 6.25. You could also put whatever the fraction equivalent of that is. And that is our answer. Now, once you set up the equation, you could absolutely just type this into Desmos and be done with this question in like 10 seconds. Really, all you have to do is make sure you change the k to x, and that's it. Now, even if you didn't know this at all, you could just type the original equation into Desmos using the method I taught in Desmos lesson number 1. And the only thing is there's going to be like infinitely many solutions because it's going to intersect a bunch of times. So you just look to the right of 0 and click on the very first point of intersection. So you see 6.25. That's going to be the answer. The only thing with this is not only is it, I feel like, more work, but you also have to be cognizant of the fact that when you click on that wrench in the top right corner, Desmos defaults to radians. So before you go to do that, assuming this is a degrees problem, which, as I've said multiple times, the vast majority of the time it is, you're going to have to click that little button to change it to degrees at the beginning of the question. I don't know. I feel like it's just so much easier to just remember that they add up to 90 and just type that in. Again, you also want to practice doing it by hand for your algebra skills. All right, let's keep going. Okay, lastly, we have property number 2, complementary to trig. So the opposite of what we just learned is also true. If x plus y equals 90, then sine of x is equal to cosine of y. Or also, cosine of x is equal to sine of y. Doesn't matter. You see x and y, it's commutative, so x and y, you can swap them out however you want. In words, you could remember this as kind of what I was saying at the beginning. The sine of one angle is equal to the cosine of the other. If they add up to 90, the sine of one angle is equal to the cosine of the other. And once again, guys, remember 90 degrees is equal to pi over 2 radians, just in case you ever, I don't think you will, but just in case you ever see a question with this, with a pi over 2 in it, that should jump out at you. Pi over 2 is 90 degrees. All right, so 2 problems on this. Well, I look at this picture, and I see angles A and angle B add up to 90. These are acute angles of a right triangle, like we talked about at the beginning of the video. So I'm going to write that down just for the heck of it. It's not really relevant. And since they add up to 90, the sine of one angle must be equal to the cosine of the other. So I'm going to write sine of A is equal to cosine of B. And if sine of A is 12 over 37, that means cosine of B is also 12 over 37. And that's our answer. Once again, very deceptively easy question. And just want to point out, guys, you also could have written sine of B equals cosine A. But you see there is no sine of B or cosine A in the question. So it's not helpful for this one, but that could have maybe been helpful for a different question. So just so you know, there's kind of like 2 ways to write it. Common theme here is that there's 2 ways to write it for every scenario. You just kind of musical chairs the sine and the cosine. Great. One last example. This is a really, really hard question. I would say, I want to say less than 20%, less than 15%, less than 10% of kids get this right. And they've asked this on the paper SAT like, I think 3 times already. It's the same question every time. So it says that point Q lies on segment AB. So the very first thing I'm going to do is I'm going to draw point Q. And you can kind of tell with all these angles and stuff, we probably want to connect point C to point Q. So I'm going to do that. All right, now it says you can trace with your finger. ACQ is X degrees. Let's put that on the image. And it says QCB. Okay, trace that with your finger, and let's put that on the image. That's this one. Well, all of a sudden, I notice that X and Y are complementary. They are adjacent complementary angles, just like we talked about at the beginning of the video. So that means that X plus Y equals 90, and that means that the sine of X is equal to the cosine of the other. So both those values at the end of the question are the same. Well, if I don't know what it is, but let's say, for example, just pull random numbers out of my hat. If it was like 0.7 minus 0.7, it's going to be 0. So you can't really figure out what cosine Y and sine X are, but you know that they're going to be the same. And when you subtract 2 identical quantities, we're always going to get 0. I just put T there as like just some random placeholder letter to kind of show you guys that they're the same. And another really important thing to realize about this question, guys, is that the 5 and the 12 did not matter at all. That was a red herring. Most people would go and label the hypotenuse as 13 and start doing SOHCAHTOA, and that's not what this question is testing you on at all. You have to very carefully, when they tell you stuff that's not on the picture, you have to add it to the picture. And you're going to have to be really meticulous on the digital SAT to copy this down on your scratch paper, because you can't write on the digital exam itself. All right, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comment section. Let's jump to the whiteboard for the final review. Okay, everybody, let's get started. So, as we talked about in the video, if it's all right, guys, I'm going to save myself some writing with all the degree symbols. Just know that we should be putting degree symbols. It's kind of hard to write all those tiny degree symbols on a touchscreen. So as we talked about, cosine of x is equal to sine of 90 minus x. So if cosine of x is 8 over 19, then that means sine of 90 minus x, 90 degrees minus x degrees, is also 8 over 19. So that is the answer for question 1. Okay, question 2. For this one, same kind of deal. We talked about sine of x degrees is equal to cosine of 90 minus x degrees, just a cofunction identity that we have to remember. And if sine of x is 24 over 25, then that means cosine of 90 minus x is also equal to that. So that is our answer for the second one. Question 3. All right, as we talked about just above, sine of x is equal to cosine of 90 minus x. That's the formula I care about because they mentioned sine of x in the question. And so if sine of x is equal to d, then that means d must be equal to either sine of x or cosine of 90 minus x. The only answer choice it could possibly be is A. Great, let's keep going. Okay, I have sine equal to cosine. So this is property number 1. We're going to take what's inside and add them up to 90 degrees. They are complementary. So x plus 63 equals 90. I'm going to subtract 63 from both sides. And I get 27. So 27 degrees, but x would be 27. Looks good. Same deal for this one. We have cosine equal to sine. So the things on the inside must add up to 90. So d plus 18 is equal to 90. I'm going to subtract 18 from both sides. And I get d is equal to 72. All right. Okay, this picture and this context, this picture really isn't important at all. Really what's important is that they tell us that they're acute and that sine is equal to cosine. So that means the things on the inside must add up to 90. So a plus b must be equal to 90. And a is 2k minus 3. And b is 7k plus 11. We combine the like terms and we get 9k. Negative 3 plus 11 is 8. And we're going to do... now we'll subtract 8 from both sides. 9k equals 82. And that doesn't simplify at all. We divide both sides by 9 and we get 82 over 9. Why don't we go over how to do this one on Desmos, because that probably would have been faster. So I will type in here, and I'm going to swap out the k's with x's so that Desmos can plot it. 2x minus 3 plus 7x plus 11 equals 90. And I come over here and I get 9.111. You could just put that in as an answer because that's 5 characters, which is good. But I'll just come over here and do 9.1111. And then I'll hit the fraction button. And you see we also get 82 over 9. Remember, guys, if you do decide to type in the original equation with the sine and the cosine, you do have to click degrees before you do that. Great, let's move on to the next one. Okay, so same kind of deal here. X plus y equals 90. Because we have cosine equal to sine. And this is k squared plus 11k plus 40 plus 78 plus 5k equals 90. And, you could just type this in and get the answer if you swapped out all the k's with x's. I'm going to do it by hand. So k squared plus 16k, 40 plus 78 is 118, but then I subtract 90 from the other side, and that leaves me with 28 on this side. We're going to factor this quadratic. I've already gone over this in my factoring video. Has to add to 16, multiply to 28. The two numbers are 2 and 14. So we get k plus 2 times k plus 14 equals 0. So k plus 2 equals 0, which means k equals negative 2. Or k plus 14 equals 0, which means k equals negative 14. Now what we'd have to do is, guys, remember they said that angles are acute. So we're going to check to make sure that they are both acute and add up to 90 before we move on and get the final answer. So why don't we go to Desmos just to make that a little easier. It'll just save me a ton of time. So I'm going to do x of k equals k squared plus 11k plus 40. And now I'm going to do y of k equals 78 plus 5k. And again, those graphs aren't really important. I'm just trying to compute the value. So let's do, what was the first thing we got? Negative 2, x of negative 2. It does not like that. Okay, let me retype it in. I'll just call it angle A of x. X squared plus 11x plus 40. Let's call this guy angle B of x equals 78 plus 5x. And now we're going to do A of negative 2 and B of negative 2 for the first value. Okay, so I get 22 degrees and 68 degrees. Both those seem good. Do you see what I'm kind of looking for here, guys? If we got one that was like negative or like bigger than 90, then the solution would not make sense. That would be an extraneous solution. But this one's good, so that one's good. Now let's try negative 14. Okay, so we get 8 degrees and 82 degrees. Those are also both acute, both between 0 and 90, and they do add up to 90. They're complementary. So it certainly seems like we did a good job. So now all we're going to do is we're going to find the positive difference between the two k values. So like the question says, so we can do negative 2 minus negative 14. And if you're ever unsure if you picked the bigger one or the smaller one, you know, for example, let's say I guessed wrong, or I interpreted which one was bigger. You could just put absolute value bars around it to find the positive difference. Great, so the difference between these two guys is 12. And that is our answer. Let's come back over here. Okay, these are the acute angles of a right triangle. So they are complementary. So by property 2, that means that the sine of one angle is equal to the cosine of the other. So cosine of A is equal to sine of B. And if cosine of A is equal to 23 over 59, then sine of B must also be equal to 23 over 59. Great. Okay, so for this one, same kind of deal. I'm going to draw a point, label it Q, and then Q, ACQ. Okay, ACQ. That is X. And then QCB, that is Y. And it says sine of x equals 0.85. Well, the sine of one is equal to the cosine of the other because they're adjacent complementary angles. See that 90 degree angle is there? That's how we know. And if sine of x is 0.85, then cosine of y must also be 0.85. So the value of that expression is 0.85 plus 0.85, which is just 1.7, and that would be the answer. Great. Okay, question 10. By the time you guys see this, I should have shorts on this that have come out. Inscribed angles, and there's going to be a short on what this shape is called. It's called a delta. I call it a delta quadrilateral. Please make sure you watch those. Anyway, I'm going to just go over this really quickly. So this is what's called an inscribed angle. So the inscribed angle is the arc that it subtends is equal to double the inscribed angle. So 45 times 2 is 90 degrees. So this arc here is 90 degrees. And you can maybe tell by reading this question that we're going to need to like draw some radii here. So let's do that. And you can kind of tell, right? The central angle, which is what this guy is called because it's the angle made with the center, is equal to the arc it subtends. So that means this guy is also equal to 90 degrees. And again, please watch my short on this shape. It goes over it in way more detail. This shows up on the SAT once in a while. I'm now going to connect these guys just so that the angles we're about to draw, you guys can see it a little bit better. All right, so this looks really similar to stuff we've done so far. Okay, CDF, why don't I call that X? That's the first one, just for the sake of simplicity. And then DFC, oh, that's that one. Okay, so this one is Y degrees. Oh, they are the acute angles of a right triangle, so they must add up to 90. They are complementary. So that means the sine of one is equal to the cosine of the other. And that means this expression is equal to something which I don't know minus something else which I don't know. You ever subtract two identical quantities, you always get 0. Okay, that's it. Let's go back to the slides. Okay, everybody, thank you so much for watching. Please comment below your thoughts on this video and worksheet. Did you find them helpful? Be sure to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by and good luck studying.